Hello, everyone, and welcome to today's exciting webinar, which is our first virtual panel discussion. I am Tim Stark, and I'm the host of today's exciting event. I'm a professor of civil engineering at the University of Illinois and the technical director of the Fabricated Geomembrane Institute, or FGI. This is our 8th webinar of 2020, and the remaining 9 webinars for 2020 have already been scheduled with great speakers and timely topics, which are available on the FGI website. And the next webinar will be announced at the end of today's event on the last slide of the presentation slides. During today's panel discussion webinar, we welcome questions and comments from all the attendees, which can be typed into the question box in the control panel. You may send in your questions at any time during the panel discussion, and our panelists will address them during today's session. The recording of this webinar and a PDF of the slides will be made available on the FGI website after today's presentation. PDH certificates will be sent automatically to all attendees who attend the entire webinar. Okay, I'd like to introduce our 5 distinguished panelists for today's virtual panel discussion titled Constructed with Fabricated Geosynthetics. So here we go. Our first panelist is Pat Elliott. Pat is the Director of Installation Services for Raven Engineered Films through their subsidiary Raven CLI Construction, Inc. Raven is a leading manufacturer of high-performance geomembranes, providing full-scale conversion, custom fabrication, design build solutions, and certified installations. Pat is also the current president of the FGI. Okay, our next speaker or panelist is Ron Frobel. Ron Frobel is a registered engineer and owner and principal of R.K. Frobel and Associates Consulting Engineers in Colorado. Ron has over 30 years experience and is an internationally recognized technical specialist in the field of geosynthetics and geomembranes and installations. Okay, next is Doug Hiltz. Doug Hiltz holds a BS degree in civil engineering and is a registered PE and structural engineer in multiple states. Doug is president and founder of Hiltz Consulting Group with more than 30 years of experience throughout the U.S. and internationally. Doug's recognized as a technical specialist in reservoir caps or geomembrane floating covers and liners for reservoirs. So Doug, thanks for joining us. Next up is Dan Rowe. Dan Rowe is president of Environmental Protection, Inc., and a graduate of Michigan State University. Go Big Ten. He's been involved in the factory fabrication and installation of geomembranes at EPI for over 20 years and millions of square feet, including the Columbus Upground Reservoir project. And our last speaker is Duff Simbeck, who's vice president of Simbeck and Associates and a graduate of Harvard University. He's been involved in the field of installation of geosynthetics and project management for 22 years, including a number of projects across the country from North Carolina to California. So Duff, if I can turn to you to start things off and explain to the attendees how a project would differ from looking at it with factory fabricated panels versus field fabricated rolled goods.
Thank you, Dr. Stark. That slide of a Montana wastewater project that's finishing up this week, the last panel should go down today, involves 56 prefabricated panels out of a plant in Michigan. Our fabricator there did extensive quality control and got those out on a timetable. So we're excited to finish that up this week. And this layout shows you really what we focus on when we get a lead, when we look at what jobs we want to bid on the front end, and we do our initial analysis of how the specs look. And if it's too much for us to handle, of course, we don't go after it. The second thing that the initial layout tells us is, what's the engineer thinking? Can we tackle this? And how long would it take us to do a job like that? The summary at bottom shows the total lineal foot of field seam. And so a job of this size, 12 acres with prefabricated panels, we'd simply look at 8 to 10 days for top, standard quality control in the field work. Contrast that now with the next slide, which is a New Mexico wastewater project that we bid this year, looking at 2021 installation schedule. This is the kind of 53-acre job that we wouldn't even go after if it was during the third and fourth quarter, because this would mean we're on site 3 months. So the magnitude of all the quality control, doing everything to the spec as required and satisfying all the regulators and ultimately the owner, the magnitude takes us out of even bidding a job like this unless it's a winter job, and that's why we participated. All these two layouts suggest is that there's so many factors an engineer looks at. Suitability of the liner is number one. Budget is big. And, is he going to get general interest from a lot of fabricators, a lot of installers to give the most competitive price for the benefit of the project? And so these are considerations that we see across the country. And even though the Montana and the New Mexico wastewater jobs are the same application, it takes us 2 to 3 times as much resources in order to install and get the job signed off. So that's just an intro on why we, from the get-go, always differentiate between a fabricated panel job and a roll goods job. I look forward to the next few questions, Dr. Stark.
Great, thanks, Duff. And just to warm the attendees up a little bit before I ask them to submit questions. So let me make sure all the attendees know what we're talking about in the beginning. So on the left is a photograph of a factory fabrication situation. So you can see a lot of geomembrane out on the floor being seamed in the factory, clean conditions, constant temperature, making the seaming very easy and consistent. And we saw that with the Columbus Upground Reservoir project. We've written several papers that show the seam strengths are much more consistent and higher with factory seaming than field seaming. So on the right, of course, is field seaming, where, of course, dirt and moisture gets into the seams. It has to be cleaned before you try to weld it, and it's time consuming and difficult, and that leads to less consistent and lower seam strengths. And again, we saw that with the Columbus Reservoir project. So how do we get these fabricated panels to the field? You can see on the left, one is being seamed, and on the right, sorry, and on the left, you can see that panel is being folded up, and they get folded up and either in accordion fold, as you see on the upper left, or you can roll them up in the factory, and then those panels are shipped to the field. And in the lower right-hand corner, you can see a few people getting some air under the panel and then pulling it into place in the field. And in the factory, complex geometries of the site can be already fabricated, as you saw with Duff's two examples. Those were not perfect squares or rectangles. They had different geometries that can all be prefabricated in the factory. What's on the screen are some pictures of a water canal that obviously has a curve in it, and that's all prefabricated in the factory, and that speeds up the installation. Okay, so the attendees online, there's almost 200 attendees online. Please submit your questions for the panelists via the question portal on the GoToWebinar control panel. If we don't get to all of the questions today, we will be addressing them in the follow-up podcast that we'll be recording in a week or so. So please, everyone that's listening today, please start sending in your questions, and I will start posing them to the panelists. First question for our distinguished panelists. Is there a maximum size the panels can be prefabricated? And maybe, Pat, why don't you take that one?
Yeah, I mean, that's a loaded question for many reasons. It really depends on weight. So all the materials have a very specific weight. So typically I as an installer and a fabricator, I prefer a panel in the neighborhood of 5,000 to 6,000 pounds. Once you start getting over those large, that large weight, you begin to make it difficult to pull and install in the field. So it really changes, how you're doing your installation. But it's not unheard of if we're doing a remote location to build panels up to 1 acre in size. And depending on mill thickness and weight, sometimes it's easier to get a number of guys or equipment to get that panel deployed. So, yes, there is a limitation, but it's usually depending on weight more than anything.
Great. And Pat, depending on the weight or unit weight of the geomembrane or weight per square foot, generally the panels are on the order of like 150 to maybe 200 feet. Is that a ballpark?
Yeah, I would say 15 to 30,000 square feet is a nice median range, but I'm not that's not, I don't want to define it as that, because we fabricate panels all the way down to 5,000 square feet and all the way up to 50, 60,000 square feet in some of the lighter mills. So but I would say on an average for construction, ponds, you're looking in that 15 to 30,000 square foot range.
Okay, great. The questions are rolling in here, so I'm going to hit them pretty quick. Next one, and maybe Ron or Doug, what thicknesses and liner materials can be folded for prefabrication? Or anybody who wants to jump in?
I'll hit that. The thickness is really limited on fabrication, and personally I'd like to see something less than 45 mil in prefabrication, but they have been prefabricated up to 60 mil. So anywhere from 20 mil to 45 mil is optimal for prefabrication. And anything more than that, of course, increases your weight and decreases the size of the panels that you're placing.
I think the material also comes into play. Certain materials are more friendly in terms of folding. I think you need to look at the material, and when it's unfolded at the site, are those wrinkles or those creases from the folding going to be removed and pulled out and not damage the material that would shorten the life of the project?
Okay.
Yeah, and I also think it depends on the fabrication method as well. I mean, you can flat wind up and you can do extremely long panels on a flat wind up, and then your thickness doesn't necessarily matter as much. Then once again, you go back to your weight. So we fabricate up to 90 mils. It's not unheard of. But once again, that really, that changes how you look at the job and how you approach the job and how you fabricate the job.
Right. Okay, next question. Is panel length / area dependent only on the factory floor area and or shipping weight? Pat, you just talked about shipping weight, but why doesn't somebody talk about area of the factory floor?
I could talk about that. The factory floor is not really a limiting factor. It certainly creates some challenges to make panels longer than your factory, but there have been times where we've actually made panels out in the parking lot, laying down a geotextile first and then fabricating on top of that geotextile, because this particular requirement was longer than the factory. There are setups with machines where a machine can be set up with rolls, where the rolls all get laced together and the machine basically starts and runs till the end of the rolls, and that operates at a relatively small footprint. So there are different methods and different ways to be able to make panels that are longer than the factory, but those are additional challenges to factory fabrication. But for the most part, I think most fabricators are operating within the confines of their fabrication building. That's the easiest way to do it and makes the most sense. Making panels that are extremely large can sometimes create just as much work for you in the field and are somewhat counterproductive.
Okay, thanks. Next question, and again, we've got a lot of questions here already, and this one's kind of loaded. What is cost per square foot for factory fabricated geomembranes versus a rolled geomembrane? Now, if I could jump in first, we have created a calculator, and it's on the FGI website, that can give you a comparison, not a cost estimate, a comparison between, say, a factory fabricated project and a rolled good project. It is not a cost estimate, but you can get a comparison of the differences in cost. So who wants to tackle this one?
I can take it.
Go ahead, Pat.
So once again, that is a loaded question, because you have to find the right product that you're comparing. So you can't just say, well, I'm going to compare this roll stock to this product, because these products act and have different properties and can do very different things. So in general, rolls to the site, you might pay a little bit more for a fabrication, obviously, because you've added a step. But what we found is most of the time we can make that up in the field production. So while you increase your cost delivered to the job site, you decrease that on the installation side. So a lot of times it's a wash. But once again, you cannot, that's not a statement or a blanket question that you can answer, because there's so many design factors that go into that, into comparing this field install versus a fabricated product, because there's several different versions of both of those products, and either one can drive those costs up.
Okay.
Well, you also have the issue of prevailing wage, field prevailing wage. So if you have a project that is prevailing wage in the field and the factory isn't, that could be a huge factor then in terms of spending additional field labor at that higher rate. Absolutely,
that you make up ground very, very quickly on a prevailing wage project, right. especially on the coasts. Here in the central part of the country, we don't run into those higher wage rates as much, but on the coast, you absolutely make up a lot of ground very quickly using a fabricated product.
Yep. And anybody else want to jump in? Okay. So again, let's see. Dan, Ernie, there's a calculator on the FGI website that walks you through the different items that come into both factory fabrication and field fabrication. And it could be used as a comparison, not a formal cost estimate. So if you can't find that, email us. Okay, next question. Can you prefabricate geomembrane panels for landfill liner systems? And I'm going to let somebody else, but I think I know the answer. That one. Go ahead. Who? Duff, you want to jump in on that one? Or Dan?
Absolutely. It's not as common, but it certainly is a suitable product in many cases for a landfill liner. And different regions of the country have a preference already in mind at the design level. And as an installer, we just adjust to what the specs say. And often my estimator will put some notes and say, would be a lot nicer if we could deal with some big panels based on this alignment and based on the application, but I don't think that the design or the that particular region is open to it. So again, there's so many factors behind that question. Why do I see a lot of fabricated panels in landfills up in the northern states, but I don't see them so much in the southern states? Part of that's regulatory, and a big part of it is weather and familiarity on the part of the engineers.
Yep.
There's a lot of national contracts out there that affect that as well.
Yeah. Okay. Next question is, in the previous pictures that I guess I showed, the geomembrane being fabricated was PVC, but for an HDPE 1.5 millimeter thick, can you make a panel? If you can, how do you fold that to avoid ruptures?
In short, the answer is no. We do very with polyethylene or with HDPE. We do some very specific, small detail type stuff, but for the most part, you do not want to fold or crease HDPE. So the answer is no, in short.
Okay, no folding and making panels with HDPE. Okay, next question. Do you think third-party testing of the material, factory seams, and field installation is necessary? That's a good one. Go ahead, Pat.
Absolutely. We encourage as much third-party testing as possible. There's, the liner is only as good as the quality control. So we encourage third-party testing in all aspects of the project. It drives costs up, but it also, it can save you money in the long run if you have an issue. So while we don't see it very often in the factory, I'm not going to say we never see it, because we absolutely do, but for the most part, it's very limited in the factory as an industry standard. In the field, it's pretty common, and yes, it is a good thing, and it decreases the owner's risk.
Okay. Here's a follow-up on the previous HDPE question. How do you install prefabricated HDPE 1.5 millimeter thick panels on filled lagoons as final covers, or is this possible at all?
Are we talking about covering the lagoon?
Yes.
While it's
So,
full?
as a floating cover?
It doesn't say.
I think what they're getting at is the HDPE would be assembled on site and then floated across the water. But that panel again would typically not be made in the factory. That would be assembled on site in the fields right next to the lagoon and then floated across the water, but not factory fabricated.
Well, they're saying factory fabricated. Could you do it with factory fabricated HD? And no. I think Pat answered.
I would not suggest it.
Okay.
Not HDPE. Lower densities, yes, absolutely. There's several products out there that are lower density that can handle that and do very well in that application.
Okay. Next one. If you were a landfill owner, which method would you choose? And I assume what they're asking, which method being factory fabrication versus field fabrication. If you were a landfill owner, maybe we'll turn it over to the two designers here, or engineers. Ron and Doug, what would you say to the landfill owner?
Well, yeah, it depends on the material that is being, specified. I mean, it was already brought out that some regions require HDPE, and it's mostly from historical or EPA regulations. If the landfill cells are very, very large, it's a really good idea to take a look at prefabricated panels for rapid installation of material. And I think Duff had a very good slide of the number of seams that are involved in production seaming for HDPE, for instance, even though they're 22.5 foot wide. The seaming and CQA requirements on large panels in a landfill application are much less. And I think the owner should look at that. I mean, as far as reducing the number of seams and the amount of QC and CQA that's required.
Well, and back to your point of you see a lot more fabrication in the north because you reduce your exposure time as well, because most of your landfill designs require some sort of compacted clay subgrade. And if you get a rainstorm after that subgrade's already been prepared, it's going to cost you a lot of money reworking that subgrade. So you reduce your risk and your exposure every day you eliminate on site. And those are unknown costs. So when you're budgeting a project, you don't know what rain you're going to get during that. So the only way to do that is to reduce your exposure time on the job site. So that's where we see factory fabrication coming in the northern states more, because they want to reduce that time on the job site.
Yep. So I move back to Duff's slide where he has field fabrication, and Duff, maybe you can talk a little bit, but you have at the bottom of this slide almost 25 miles of field seam that not only have to be performed, but checked. And if they don't pass, of course, fixed and so on. So why don't you compare that with the prior slide, which is right here for the factory fabricated panels?
Right, the factor that Pat mentioned about the inevitability of weather impacting your schedule impacts, the contractor, the inspector's time on site, and of course the budget from the get-go. So that variability leads us to be more inclined to bid on a job like this Montana fabricated panel wastewater lagoon than to go after the huge job where it may be 64 days forecast with perfect weather, but there is all the complications of the extra testing, the extra lab costs, and when you get shut down to a storm and you got to remote 3 or 4 times to finish that job, then it becomes a scheduling nightmare for all levels of all parties involved on that project.
Yep.
Well, and as you're talking there, Duff, I'm kind of doing some simple math in my head, and I'm looking at the Montana project, 12,000 linear feet of seam over 12 acres. So you're getting a little over 2 miles versus the other slide, you have 25 miles and 50 acres. So just in those projects, you're looking at about, 8 to 10 miles of seam versus 25 miles of seam. And we've done layouts. And so we've done these comparison layouts before, and we can see a reduction all the way up to 70% of field seams.
Yeah, again, which impacts the budget, impacts the willingness to be competitive on our pricing on the front end, and of course, all the wrinkles that develop when you have any problems with weather and not getting the job done for the winter, and you got to start again in the spring. I mean, it just goes on, and your variability makes the roll goods projects a lot more difficult to tackle.
Okay.
Well, and you guys are all talking about time on site and installation. I think another really important thing to point out is the amount of time on site for CQA, the amount of time on site for the contractor who's moving dirt, all the other time and all the other components of the project and all the other milestones that are backed up behind you. So you're on site for 8 days. Well, after 8 days, the contractor can get back to work instead of 16 days or 20 days or however long it takes. And to that contractor who's working in Montana for the summer, time is money. It's precious. You only have so much of it. And that's the real advantage of a prefabricated panel. It's time is money.
Okay. Thank you. All right. Now I've got a specific question for Ron and Doug. It says, for Ron and Doug, what factors do you use to determine whether to use factory fabricated materials or roll good only materials?
That would depend on the application and chemical resistance of the material, specifically for the polymer type of material. If we can open it up past HDPE, of course, I would use roll goods. And if it's not subject to fabricated panels. And quite honestly, all the discussion so far has pointed to cost savings, and it is extreme cost savings when it comes to installation of large panels in large areas. And this is also for soil cover operations, where we have a contractor that's got to place 12 to 18 inches of soil cover over a lining system, and we can fabricate a panel to the proper size that he can cover that within a day or less, properly compacted. Whereas with strip 22.5 foot wide HD, if it's going to be covered, takes a lot more time and effort. So it depends on the application, chemical resistance requirements, and the size of the project.
Doug, why don't you weigh in?
Yeah, I would agree with that. I think the main thing is your material selection, and Ron mentioned that is if you're dealing with an HDPE, it kind of naturally lends itself to roll goods just because of the material. If you're looking at other types of materials, then I think there's somewhat of a trade-off, cost, time on site. Me personally, I tend to sway more towards fabricated panels just for a variety of different reasons. But if it's a non-HDPE project, in most cases, I think you end up with a better installation. Just the quality, the cost, less time on site, if you go with fabricated panels.
Let me focus in there, Doug. You said if it's an HDPE project or a non-HDPE project.
Right.
What do you mean by that? How can a project be just one or the other? I mean,
well, it depends what material is ultimately selected. And then from there, I think you can do the analysis, is it a good candidate for prefabricated panels or not? If you're dealing with some of the projects that have narrower roll stocks, trying to just deal with roll goods on a site you're burning a lot of labor out in the field and under more difficult seaming conditions. So the wider the panel and the stiffness of the panel, or the material, not the panel, but the width of the material and the stiffness of the material, I think are key factors, along with the cost and the exposure and the application, as to if your prefabricated panels are just doing strips in the field.
So we need to get the engineer that's specifying the project to consider a variety of materials, and then let the cost and installation quality determine what's the best fit. Is that what I'm hearing?
I think that all needs to be done at the design side, and not
Right.
necessarily make that in negotiations during construction or during the bid period. I think ultimately, projects I'm involved with, the engineer typically will make that assessment with the owner in terms of what's the best material and what's the most cost efficient material. And it's not necessarily the cheapest, it's providing the best value for that specific project. Are you looking at a 5-year project, or are you looking at a material that you want to get 30, 40, 50 years out of? So the value and the cost somewhat go hand in hand, and both need to be evaluated.
Yeah, we do a lot of assisting of design engineers. You know, they'll call in and we'll talk to them, and it's almost like I ask a series of questions, and it really depends on the site specific. I mean, chemical resistance. What are you putting in this? Well, that may eliminate a product right there, because a certain product doesn't handle that. You know, slope length. You know, we're doing a very large project right now locally here in Colorado, and it's got 200-foot slopes, and I don't want HDPE on there because of the expansion and contraction. I'm going to end up with a floor wrinkle here at the end of the installation that I'm not going to get rid of. So I want a reinforced product on that project. So it's almost really specific to the constraints of what you're trying to accomplish with the project. And then you slowly eliminate the products that won't work. And then you're left with, okay, well, we might be able to put two or three different products in here. Now we can go, okay, well, let's look at the cost, let's look at the layout, and then you can kind of pick one of those from the cost. So it's almost really understanding each project and treating each project individually. And I think that's where our industry has failed over the last, many years, is we just, because we had some great salesmen in the 80s selling HDPE, we shoehorned a lot of projects into HDPE, and then the installer gets left holding the bag to put that HDPE in, or because that's just what we've always done. And so I really, as supporting engineers from our standpoint, because we do all the products. We don't differentiate and enforce people into certain products. So I really help them understand their project, and then we pick the product that will perform in that project. So that ultimately, to me, is how I assist engineers in it.
Right. And it's going to vary
as a
design, cookie cutter solution.
Right.
Mm-hmm.
I suggest as a design engineer, if you're looking at different products, to take a look at all of your design considerations, everything in the project, everything. Make a tabular decision-making tool, list 5 or 6 different types of lining systems, and go at it and see, which one you're going to choose. I mean, it's not just one product.
Yep. That's great discussion, and I think the takeaway for all the people online is the design engineers should contact the fabricator, installers, and manufacturers and let them explain the different materials and how they might or might not work, as Pat said, to your particular project. So, okay, I've still got a bunch of other questions. Let me move on. I am a geotechnical engineer. Will you discuss subgrade stability requirements and problems you've seen? So Dennis, there is a document on the FGI website called subgrade preparation. It was developed by the FGI. It gives you ideas of allowable rock sizes and so on before you can place a geomembrane. So please visit the FGI website, and I'm going to turn it over to our panel members. Who wants to cover subgrade stability requirements?
Well, I'll just point
I
out
can
that
hit some of that.
Okay, let's start with
The
Ron, and then I'll go to Duff.
okay.
Go ahead, Ron.
Well, subgrade stability is extremely important in any of the geomembrane types that you're going to be placing, because you don't want settlement, you don't want stress on seams and the material itself, and you don't want large rocks in there. So you really have to look. If you don't have a proper soil base to install on, then you have to bring in import material so that you can compact it to, say, greater than 95% standard Proctor and get it roller compacted smooth. If you can't get it smooth and you have a lot of rock, then you have to look at other options, including geogrids and geotextiles as sub-layers within the soil. But we've placed lining systems over extreme conditions, and again, you have to fortify the subsoils and make sure that material is not going to deform under loading, for instance, during equipment placement of the panels and over time for whatever loading is going to be on that system. So you have to design your base soils for the lining system itself.
Okay, Duff?
I'd simply add to Ron's comments that you don't have just the one chance to address all these issues and at the design phase. You also have the submittal phase. And that conversation should carry on between the contractor, the installer, the inspector, the owner's rep, because you can adjust on the fly and take care of some unanticipated factor. And so everyone being on the same page at pre-con, at the submittal approval, and then, you know, the first 2 weeks on the job, how's it going? Are we confident in our subgrade? That's big. And at that point too, you have the conversation about over compacting. One of my bugaboos is where the specs say, first, last, and always, you have to compact your perimeter anchor trench in 6-foot lifts. And it drives me crazy because that is over designed, and it's going to stress certain liners to the point where you're going to have to come back and repair stuff. So that's the conversation we try and inject at the submittal phase and say, please, please, please don't over compact or fill that anchor trench with concrete. You're spending a lot of money, and with a polyethylene product, you're risking a whole lot of damage. So again, it's not just at the design phase. Keep the dialogue open and keep everyone on board for the good of the project.
Okay. No, still a lot more questions. Can LLDPE be folded without damage?
Yes.
Okay.
Yes, we do a lot of fabrication with LLDPE and reinforced LLDPEs. So yes, it can.
What thicknesses?
It really depends. I mean, we do 60 mil. We do 60 mil reinforced. We do yeah. So I would say that probably 60 mil is the thickest. But when you're dealing with a reinforcement, you typically don't need a 60 mil. A 45 mil or even a 36 mil is going to perform like a unsupported 60 mil will.
Okay. Is there a modulus that's too stiff for factory fabrication?
One of you smart folks is going to have to answer that one.
Well, modulus is a measurement of the elasticity or the flexibility of the geomembrane. So as your modulus goes up, your material is thicker, or your material is less flexible per thickness. So the answer is yes, but it's not a specific number because it's going to vary greatly from one material to the next. So I'm sure at some point there is a lack of flexibility that is detrimental to every material. But that's too broad of a question. The answer is yes, it depends on every material.
Don't you think it also depends on your packaging of those prefabricated panels? Meaning, if you were trying to fold a material, that stiffness would become more of a factor, as opposed to if you were making fabricated panels and rolling those panels, that stiffness would be less of a factor. So that packaging kind of comes into play, and then you get into issues like shipping and trucking. If you're dealing with like a stiff HDPE, you're probably looking at 2 roll stocks, and you're 45 feet long, and that's about the max you're going to want to truck. You don't have the benefit of adding a 3rd roll stock of HDPE because of the trucking issue then. So I think the packaging of those panels comes into play in that answer.
So I was referring to the modulus, of course, of the geomembrane, right?
Right.
Which I think all of you understood. The next question that just came in is there a minimum subgrade modulus then that we should shoot for before we place the geomembrane?
The stiffer the better. I mean, it's you probably want to have a decent modulus for the soil itself. I mean, you don't want any deformations in there, both during installation and after installation. So it's going to have to be a very stiff subgrade, or you have to go in there and place high modulus materials such as geogrid to resist any movement of the subgrade during use.
Yeah. So Ron and Doug, maybe this is the way to tackle it for the engineers that are asking about the subgrade. Are we talking about relative compaction based on standard Proctor compaction or modified Proctor compaction, of course, which is about 5 times the energy? What would you recommend them specifying to modified or standard Proctor, and then a relative compaction maybe of like 90, 95%?
95% standard Proctor.
Oh, just standard, not modified?
No, yeah. I would go with standard Proctor.
Wow. Doug?
I agree. And I think what we're really looking at when you're preparing the subgrade is you're looking for something that's going to be smooth, uniform. It's your settlement, but also your differential settlement that are going to be concerns. If you get a lot of differential settlement, you have you're asking that liner material to deform to the settlement of the soil. So I think those are 2 key factors, and I think it comes back to your compaction, 90, 95%.
Okay, great. For the attendees, looks like 90, 95% based on standard Proctor, not modified Proctor. So that's very important. Okay, here we go. We got a whole bunch coming in now on subgrade. How much settlement is acceptable in the subgrade to protect or hold the seams? Wow.
That's a loaded question. Your liner design. I mean, for example, some of your liners can handle differential settlement a lot better than other liners. So, I typically don't like to see any differential settlement because you're going to get pinch points and you're going to get stress points on that liner. So I believe you should try to design out of that using other geosynthetics or other methods of subgrade preparation. So I don't know if there's a specific number, and if there is, it's going to be based on each product.
Okay.
I think you're right, Pat. The less the better. And I think it also comes into play as to what is your liner system? Where do you have those slip planes? If you're dealing with a textured material that's wedged between, let's say, geotextiles, you're not going to have much slippage. If it's a smoother material and a smooth soil or a geotextile, you have the ability for that liner material to slip and move somewhat. So it's just a matter of how much elongation and over what distance do you think the liner is survivable?
Right, and it also depends on if you're covering the membrane, because now
Right.
you're loading it with soil versus loading it with water. So there's a lot of factors that play into that.
Right. The takeaway is the less the better.
Right. So panelists, we have about 5 minutes, and I'm telling you, there's probably 20 questions we haven't even gotten to yet. So we're going to have to do some of these in our podcast. So let me stick with subgrade. Discuss maximum particle size for subgrade materials. And again, we have recommendations in our FGI guideline, which I think is, well, let me ask you what your maximum particle size is.
I'd like to see somewhere around 3/8 to ½ inch. And that would be loose particles on top of a hard roller compacted surface. Anything more than that, you're asking for issues with potential puncture.
Okay, I think our FGI guideline has either a 1/4 or a ½ inch, so 3/8 is right there. Anybody else want to weigh on maximum particle size?
I think it depends. Are you laying the liner directly on soil, or do you have a geotextile?
Soil. The question's all directly on subgrade.
Okay.
Yeah. Okay, keep going. Where was I? So generally there won't be zero settlement. That's not practical. So what would be, do you have an allowable settlement for a subgrade with a geomembrane?
No.
That's entirely dependent on the type of material that you'll be using. I mean, if you've got a PVC material that you're placing and you have overburden, obviously you have soil cover on top of it. Sure, there's some allowance there for settlement, and the PVC will take it. Whereas a material, say 40 mil HD or something, you have to look at the yield point. So you really don't want any settlement at all. So it depends on the material and the type of soil conditions that you have and that you can't get away from. But I would say way less than 10% of any movement.
Okay. So maybe we've just got a few minutes. So here's a great question to end. I'd like to ask the panel if there are any new upcoming materials or technologies that are going to impact the fabricated geomembrane industry in the next 5 to 10 years. Are there any specific technologies that the panel would like to see developed? So let's go around the table. Who wants to start? And I'll go from there. All right. Dan,
I don't know. I'll take that one. I'll start with that one. I don't know that there's manufacturers are always developing new materials, and I don't know. You know, there's lots of different technologies for welding seams in the factory, in the field. There's lots of technologies for testing, spark testing, electric leak location testing. We have a lot of technology at our fingertips right now. I would love to see owners, engineers, designers using the current technology before we really look for new stuff. Some of the things like leak location surveys find damage to the geomembrane that nobody knew about, that can pay for themselves in a heartbeat. I just looked at a specification for a project that had water balance testing, which is, I had hoped a long time ago that method was dead, but people are still using it, and it just doesn't work. It's silly, and I know that there's other technologies out there. I know that manufacturers are all developing new types of materials, and we're growing as an industry from where we were even 5 years ago, especially 10 and 20 years ago. But I would love to see some of the current technology actually utilized as much as I'd like to see new technology come around.
Okay, I'm going to go around the panel. Doug, you're next, and then Duff.
As far as new materials, I would leave that to the material manufacturers. They have the R&D departments that are probably tracking that and going after that. I think there is some opportunities for some enhancements in some of the existing materials. In terms of other improvements in the next 5 to 10 years, I would like to see more sophistication in our QA/QC programs, particularly out in the field, and some of the seaming equipment and documenting where repairs are and problem areas. I think the overall QA is something that could be bolstered and improved through the use of technology.
Okay, Duff, and then Ron.
I'll agree with what Doug said about some potential technologies, but there's that hazard of technology too, of making it so complex that not everyone understands the quality control numbers. So I tend to really conclude from Dan's commentary that the low-hanging fruit is really in improving the conversation with the existing methods that we have currently, from manufacture through fabrication on through the design and the on-site quality control. Even after the job's in, there are technologies that promise better reassurance for all parties, but I think what we have now can be reinforced and help everybody involved to understand how you best apply for the best efficiency on a given project.
Okay, Ron, and then we'll wrap up with Pat.
Personally, I'd like to see materials that maybe lower in mill thickness, that have even higher properties, chemical resistance, puncture, properties that we can use in larger panels, even using automated equipment. I know some of you guys have that. We have dielectric, we have the old machines where you can make panels that are 500 feet in length if you wanted. I'd like to see larger panels and actually less mill thickness, but we still have even more physical and chemical resistance properties. So manufacturers, you can come up with some decent new products, thinner and even more robust than we have today.
Right. All right, Pat, wrap it up.
Yeah, in short, we're doing it every day. We have an R&D department that is doing that every day, and we are looking at different scrim patterns to get higher strengths with thinner mills. We have capabilities of 7 layers in our extrusion lines where we can interject gas layers. gas mitigation layers and, you know, depending on the application. So in short, the answer is yes, we're doing it every day. And it really depends on, you know, when you talk about trying to revolutionize the industry as a whole, well, that's very difficult because once again, one product doesn't solve all the challenges that you're faced with in this wide variety of projects. So yes, in short, we're doing it every day and we're trying to solve those challenges every day in our R&D department. And I know all the other manufacturers are doing the same. So in short, yes, I think the products from the skins to the reinforcement are getting better all the time. I think we've come tenfolds in the last 5-10 years even. But I agree, we have a lot of old technologies that don't even get utilized in most of the projects. So it's an education thing, and that's what we're doing at the FGI. We're continually trying to educate and get that message out there. So that's why we're doing what we're doing today.
Okay, great. I want to wrap up with just 3 slides. Here's the contact information for all of our panelists. If you have additional questions, you can contact the panelists or contact me or Jennifer Miller, and we'll be happy to answer your questions. We have a follow-up podcast coming in about a week and a half, so if you have additional questions, please send them, and we will answer the questions that I did not get to today during the podcast. So contact information. Our next webinar is on the Yeager Airport, Charleston, West Virginia, Yeager Airport reinforced slope failure. This is a very interesting project. Our 2 speakers, Jim Collin and Ryan Berg, I helped with them on this. It's going to be a great presentation. I urge you to attend. It was the largest reinforced slope at the time. And finally, the FGI website, please visit it. We talked about some guidelines for subgrade preparation and quality control testing, and the cost calculators, among other calculators like pond leakage, are on the FGI website. Please visit it. If you can't find what you're looking for on the FGI website, please email us and we will get you to the right point on the website. So panelists, thank you so much for a great session. This was our first virtual panel discussion and I thought it went great. So maybe we'll do another one. Thank you.
Thank you, everyone.
Thank you. Yeah, thank you, Tim. Thank you, all the panelists.